All right. Hey, folks. In this video, you are going to learn how to fine-tune foundation models on Amazon SageMaker Studio using Jumpstart. So let's get started. Farouk, what do we have today?
Hi everyone. So today we are going to talk about how to fine-tune a foundation model in SageMaker Jumpstart. So with just a few clicks, you are able to fine-tune a model on Jumpstart.
Great.
Okay, so I would talk a little bit about what the fine-tuning process does when we click on the train button in Jumpstart. So the user comes in, clicks the button for training or fine-tuning the model, or they can also do it in code using the estimator.fit method. So when they do it, what happens is SageMaker, in a fully managed way, extracts the model artifacts, the pre-trained model artifacts, as well as whatever is needed to build a container, like container code, the different packages that need to go in the container for fine-tuning, and packages all these artifacts with the data that either you provide, your custom data set, or if you have selected built-in one of the built-in data sets, that data set, all this stuff is packaged in a container and then copied on an instance to fine tune the model. And once it's copied, the fine tuning job starts. And once the job is finished, you get the model artifacts and output back on Amazon S3.
Awesome. Yeah. And so just to remind folks, the reason why we're saying click is because you really can do this using SageMaker Studio. So absolutely, you can navigate through SageMaker Studio without coding. You can browse the foundation models, which we saw in a previous video. Once you've found the model that you want to work with, you can use the pre-built data sets actually to test it. And then you can also bring your own data sets. We include information in Studio about what the data set formats should look like for the fine tuning with some examples with different types of fine tuning, which is pretty cool. Yeah. And then in addition, again, you can just point to your S3 bucket, call fine tune. And then as you see in the visual here, then we create this cluster with one or a number of instances to fine-tune this model for you. The job will show up both in SageMaker Studio and in the console. You can view the logs from this. You can monitor this while it's happening. And then once it's finished, you'll get this fine-tuned model, which you can then evaluate, such as by deploying it onto another resource and then evaluating that resource.
Yes, and that evaluation also can be done in Jumpstart as well. Once you have deployed the model, you can also evaluate it.
Very cool. So what are we going to look at in the demo?
Okay, so in the demo, we are going to select a model, mixed relate into 7B model, and then we are going to fine tune that model with just a few clicks.
Okay, so what are we looking at here?
Okay, so we are in the Jumpstart console in SageMaker Studio. Here we see different model provider hubs that like we discussed in the previous video. So now let's go in and fine tune a model. Let's look at a Mixtral model. Let's look at the Mixtral 8 into 7B instruct model again. Here we have the model card showing us the different ways the prompt should be formatted and how we can what type of fine-tuning we can do in here.
And then actually if we go to the top of the page, viewers just definitely note those three big blue buttons on the right-hand side. So train, deploy, and evaluate. So as you're using SageMaker Studio, you'll notice that every model has those three blocks, and then some of them are highlighted, which means that model supports that functionality. Most of the models support deploy and evaluate, and then a good number of them support fine-tuning as well.
Yeah, that is correct. So this model, Mixtral 7B Instruct, it does support fine-tuning. So let's go and actually fine-tune a model.
Actually, before we do that, can we talk about the different modes of fine-tuning? Because they're pretty interesting, actually. So you'll see here these three different types of fine-tuning. Can you discuss these here?
Yeah, so we have, which is the first, chat fine-tuning. So you pick this mode if you want to build a chatbot, for example, and you have a data set that supports that, where you have back and forth question and chat kind of prompts in there. So that you use for doing chat fine-tuning.
Yeah, and actually, can you highlight this data set? Let's just look at this because it's pretty interesting. So Yeah, starting at dialogue and then about this Empire State Building component in the yeah, right there, right there. Let's just highlight that little block. Okay. Yeah, so for folks who if you haven't worked with chat fine tuning, what's really interesting is that an instruct model is not the same as a chat fine tuned model, as it turns out. When you do instruction fine tuning, you're just teaching your model how to follow those instructions, but it won't necessarily be enjoyable to chat with, actually. It will be a little bit too verbose. It won't be friendly necessarily. It won't know how to have a conversation. Chat fine-tuning is an additional technique that you can add to language models to make it chatty and fun and to know how to have a conversation. And so what that data set looks like is you have three roles. You have the role of the system, which is sort of you bringing the prompt template. You have the role of the human or the user, and then you also have the role of the assistant, which is the AI. Now, each language model is going to use slightly different syntax for that, and so just make sure you're using the syntax supported by that model. But definitely, if you are building a chat application, make sure you're using a language model that has been chat fine-tuned. Otherwise, it's just not going to know how to chat, and it's just not going to be fun. So definitely pick a chat fine-tuned model.
So Emily, this is an instruct model. So with chat fine-tuning option, we can still fine-tune it for chatting, right?
Yeah,
So
as long
cool.
as we have that data set.
Yeah, so
let's try it.
Yeah. Okay. So other than chat fine-tuning, we also have instruction fine-tuning, where we provide the model with instructions, label, and then we have prompts. So the model, as Emily mentioned, follows these instructions and then learns. So that's basically what happens in instruction fine-tuning.
Yeah, and so you would do instruction fine-tuning if you want to teach your model how to do a net new thing. Like if you want to teach your model how to write screenplays or how to write emails or how to do brainstorming on team activities for things like this. That's where you would just add new instructions. Yeah, and then we have this third type of fine tuning, which is this domain adaptation, which is for more broader purposes.
Yeah, that's correct. So one question, Emily, here. So for instruction fine tuning, we are basically, if a model is not trained on a specific task, we can teach it to learn that task as well, right?
Exactly, yeah.
Okay. So for domain specific fine tuning, this is used when your data set is such that it might be that these models, generative models, may not have been trained on that data set. Okay, so if you have a very domain specific data set, you use that and then you train your model on that so that it can answer questions related to that domain. All right, so let's move on and train this or fine tune this model. You click on the train button. Here it opens the fine tune model page. You can select the model artifacts which Jumpstart provides, or you can also enter the model artifact location that you may have in Jumpstart. Okay, on the data set, we provide some some data sets that you can select to fine tune the model, or again, you can provide your own custom training data set, which will be in S3. So you need to provide the location of the S3 bucket where your model will
and
be.
this example training data set is so helpful. I mean, it's great that that's already hosted, already packaged, and ready to go with this model, with this training image, with this training script, and with this infrastructure. It's super handy.
Yeah. So you can select various hyperparameters as well. You can select the type of fine-tuning, path flora, or none. These are the two options for this model.
And so remember, so PEFT stands for parameter efficient fine-tuning, and then LoRa is a type of parameter efficient fine-tuning. And so you'll pick PEFT basically when you only want to fine-tune a part of the model. So your language model, remember, is this large beast. It's large in disk, it's large in memory. 8x7b means you have many tens of billions of parameters, and it takes quite a lot of accelerators to host this model. unless your data set is similarly quite large. But if your data set is a little bit small, then you're only going to want to fine tune a portion of that. Also, when you use LoRa or PEFT, your fine tuning job will go much faster because instead of fine tuning this entire object, you're only fine tuning a tiny little piece of that. And so pick PEFT when you only want to fine tune part of the model. And then I think you can set the rest of the LoRa techniques and the LoRa settings actually in those lower right bars. So LoRa R and then LoRa dropout helps you configure that. So something to keep in mind.
So for comparison, if you pick LoRa, we have seen that it's the number of parameters that generally are modified is close to 0.1% or even less. So that's a big improvement in training time as well as reduction in cost. So if you're instruction fine-tuning the model, we select this instruction train model to be true from here. And then as Emily mentioned, we can also select different LoRa parameters here and number of epochs. And then finally, if it's a chat data set or no. Okay, so that's what we do.
Yeah, and I would probably have one of those set to false because I don't think we're so chat fine tuning is supervised fine tuning for sure, but I would just have one of those booleans set to false.
Yeah, so I have set chat data set to false here.
Okay.
Okay. Okay, there are some additional hyperparameters also that you can pick, like quantization type and various other parameters here.
Nice.
Yeah.
So notably, you can set the validation split ratio. You can set the evaluation strategy to steps, probably or epochs, I would imagine. Remember, a step is just taking a step through a mini batch, but the epoch is taking a step through your full data set. And then you can configure the number of steps for the evaluation, which is very handy.
Yeah. So this is a very comprehensive list of parameters that you can select here.
Indeed.
Okay, so, yeah, even though it's a low code, no code option, but you can do that here or in the code as well. Okay, so now let's select the instance that we want to fine tune here. We have two options here: G548X large or P4D 24X
And
large.
just a reminder, so remember the G5 instance series. So both G5 and P4 are instances that provide NVIDIA GPUs.
Yes.
What you need to know is that the G5 series tends to be smaller and less expensive GPUs that are better for, say, small scale training, fine tuning, and then hosting. Whereas the P5 series and the P4 series, those are much larger GPUs that have many more cores in those chips. And so they're much better for, let's say, like very, very large scale training. So if you're trying to pre-train your own foundation model, you'll use probably the P4 or the P5 series. Whereas for fine tuning and then hosting, you'll probably use the G series. All right, moving on.
Okay, so we also select the output bucket, S3 bucket, where we want our model artifacts and the output to go. Here we have leave it at the default bucket here, but you can pick your custom one as well. We have various security options and encryption options that you can select as well. And then finally, you give it a training job name and click on submit to fine tune the model. Okay, so once you click on submit, all that script and dependencies and packages and data set, all that packaging happens, copied to the training instance or instances, and the training process starts. So depending on the training job, it can take from a few minutes to a few hours. So I did ran a training job yesterday. So let's actually look at that one. We go here on the left in the training and click on training here. There it shows all the different training jobs.
Quite a few training jobs. That's awesome.
Yeah. So let's look at this one where I did Mixrel yesterday. Okay. You can see that here it is showing us some metrics like the evaluation and training set losses here. You can also click on artifacts and look at where your model artifacts and output are there in S3 bucket or
And
in the input.
Just a reminder for folks. So remember, This is all of the metadata about your job. So the base image you used, the source code, the content type, the data sets, the data distribution strategy, all of the details about that experiment, again, are stored for you in the SageMaker control plane. And so it makes it much easier to revert back to and evaluate work that you did, anytime. In addition to actually taking this object, which is a training job, and then putting it into a pipeline, which we'll look at later in the series.
There are various other options at the top too that you can select. You can look at what security options you selected, the hyperparameters that you selected for this training job, various configurations like where is the training image, which training image you're using, maximum runtime, and a few other options. The instances and the type of instances and the number of instances that you're training you're fine-tuning your model on.
And actually, I should clarify my statement. So when you're using, again, a SageMaker Jumpstart model, the image is obscure. You don't have access to that image, but you get to run that image on your data sets.
That's correct.
However, when you are using just the basic SageMaker training infrastructure, and you're bringing your own scripts, then when you run a training job, we'll actually make a copy of your source code in your S3 bucket, and then tag that in the job metadata so you can revert back to that later.
Thank you, Emily. You can also click on the logs tab and then look at the various log entries during the training process. Again, you can also go to Amazon CloudWatch to look at these logs as well.
Yeah, and then just a reminder, so what's happening in the training logs here is, so first we're gonna print the container information. So we'll print the environment variables for this. We'll try and pip install the requirements in your source file, and then we're actually executing your script for you. So in this log, you should see actually a line where we're calling the training script with all of the arguments that you bring, and then you can view the activity. So everything in that training image, everything that's written to standard out or just all of your print statements, those show up in this CloudWatch logs view. So when you need to debug anything that's happening, you can just write print statements to yourself in that training log and then view it here.
Thank you, Emily. You can also look at these training jobs by going in the SageMaker console here, and then browsing down to training, and then clicking on training jobs. So it will show you all these different training jobs. So this is the one which is in progress right now, and can go and click on some of the things that were shown in SageMaker Studio.
All right, great. So what are some resources viewers can use to learn more about this?
And let's look at the resources now. So we have Jumpstart fine-tuning official documentation. We have provided a link here to that. We also have several notebook examples in the Amazon SageMaker examples repository. You can go in to this link there, and you can see various fine-tuning code examples there if you want to fine-tune using code. And then we also have a video on how to fine-tune a model in SageMaker Jumpstart.
All right, thank you. So I hope you enjoyed this video. Again, in this video, we learned how to fine-tune foundation models using Amazon SageMaker Jumpstart through SageMaker Studio. We did this without coding, actually. We did this just by clicking, which was very nice. In the next video, we're going to build a retrieval augmented generation pipeline using SageMaker Jumpstart foundation models, and then we'll be writing Jupyter notebooks to do that. So see you there. Thanks.
Yeah. Thank you.